Hello, everybody. So in this short video, I am going to be using Microsoft Excel Solver to compute the shortest distance between an origin node and a destination node. You can see the diagram right here, right? The diagram can represent a road network, okay? For instance, if you look at in any city, you can have series of road network, and the road junction are represented as a node, the circle node, like all the alphabets O, A, B, C, E, D, T. They are all road junctions. And between road junctions, two road junctions, you have distances measured. Like between O and A, the distance is assumed to be 2 miles, 2 kilometers. It can be anything. Between 0 and B, the distance is assumed to be 5. Between O and C, the distance is 4. Between C and E, the distance is 4, 2. Now you want to move, you can get to T from O in several parts. You can move from 0 to A to D to T. You see, you can take you can move, if you are moving, you can move from O to A, then you move from A to D, and you move from D to T. So you can have OA to AD to DT, and you can move from O to C. You can move from C to E. You can move from E to T. Okay. Now, if you want to consider several paths, you will have several options to take. One of them will give you the longest distance. One, of course, will give you the shortest distance. So I want to use Microsoft Excel to compute the shortest distance between the origin node O and the destination node T. So I'm starting from O, I'm going to T. Which of the paths will give me the shortest distance? That is my objective. Okay, now I'm going to represent, all the nodes, the circle here, I have them here, spelled out O to T. Okay, I'm going to grab that and form what I call adjacency matrix representation. Adjacency matrix, adjacency matrix. Okay, so I'm going to form a square matrix based on how many nodes I've got, rows and columns. So I'm going to grab this and paste this. Now, I want to paste this vertically here. So I'm going to right click that cell and come to paste special, and I'm going to pick transpose. And that would give me that. Okay. Now, all the distance, the node, as you can see, from O to A, the distance is 2, right? I do not have connection between O and O. See, there is no self loop. You do not have this. Excuse me. there is nothing like this in the network. Okay, there is nothing like starting from one node and coming back to the same node. So there is no O to O. Okay, there is no O to O, and I can move from O to A according to this network, and O to A is 2. And I can move from O to C. O to C is number 4. Now, if you move from O to A, you would not move from A to O. You can only have one-way direction, because this is assumed to be what? A network problem. So what I'm trying to say here is that you can only move from O to A. You cannot move from A to O, okay? So if you consider all the options, obviously you're going to have this, you're going to have this. Hang on. You're going to have what? Oh, excuse me. I have this. So I'm going to grab that and paste that right here. Okay, that's fine. Let me rename this. Sheet 2. Okay, now you can see that from O to A, I've got 2 according to this diagram. From A to B, the distance measured is also 2. And from O to B, the distance measured is 5. Now, we don't have A to O. All those places where there is no connection, where there is no possibility, just fill them up with in any big number like 10,000 or 1,000, because of course, those parts will be useless for you, because we are actually computing the shortest distance. So all the nodes, all the paths, the edges without connection, fill them up with 1,000. For instance, there is no movement from O to O, so that is 1,000. You don't have movement from A to A, that is 1,000. Also, there is nothing like moving from A to C. See, you cannot move from A to C here. So all those impossible connections, fill them up with what? Any big number. I decided to use 1,000. All right, so I'm going to grab the entire, I'm going to call this is a cost matrix. I'm going to grab this and then paste here, okay, and delete this one. All right, so this particular second square matrix, I'm going to make it orange cell. That is where my decision variable will be in. Okay. Now, on this line, I'm going to have what is called total in. So make this cell to be, what color shall I give it? Let me call it yellow cell. Let me make, and here I'm going to call this total. I'm going to explain that in a minute. Okay, total out, and that is from, yeah. Let me call that blue cell. Okay, blue cell. All right, now I have got total out total in. Now here, let me have what is called out minus in. Is it like a net flow? Net flow. Okay. Now the yellow cell, it's just the sum of the columns here. Okay, sum all the columns in the orange cell and put them in the what? The yellow cell. Okay, so you can drag this plus, you can bring the cursor here, and when the plus sign appears, drag the plus sign to the last one. So that formula is transported into the rest cells. Also, I can sum. So what I've just done here is column sum. Column sum. I can also do row sum equals summing all orange, the rows in orange cells. Okay, then I can drag this when the plus button appears. I can drag this and bring it down. Okay, now the net flow here, let me make that color to be color green. I don't know, green. What color should I use? Okay, let me use this color. And then, so I'm going to be computing the differences between the blue cells and the orange cell one by one. So equals first blue cell, no, equals first blue cell minus first orange cell. Okay, I'm going to come here, equals second blue cell minus second orange cell. We'll do the same thing for the third one, equals third blue cell minus third orange cell. Close that, equals, open the parentheses, fourth blue cell minus fourth orange cell. Okay, move to the next one, equals fifth blue cell minus, fifth, yeah, fifth orange cell. Again, I will have this as equals sixth blue cell minus sixth orange cell. You got that, equals the last one, seventh blue cell minus seventh orange cell. All right, so that is the net flow differences between the total out and the total in. Because of time, I'm just going to show you how you can do that in Excel, okay? Any problem that you have, you can interpret it in the context of the problem. But if you follow this, it's going to work perfectly for any problem. Okay, now the nodes, let me call this node. Node, so let me grab this node from sink to source. Grab that here. So let me delete that. Okay, now let me grab this to be, let me call this a value. Now the origin nodes, I'm going to give it a value 1. That is the requirement for Excel server. And all other nodes, apart from the last node, will be 0. So this will be 0, 0, 0, 0, 0. And the last node is going to be -1. That is a sink, source and sink. Okay. Entry, exit. So you need to use 1 and -1 to show that the first one is the entry And the last one, T, is -1. Okay, so now that's how you want to put shortest network problem for shortest distance into Excel server. I've done it properly. I also need, of course, the most important part, the objective function, Z. We call that color green. Now, as usual, you will always compute some product between the cost matrix here and the yellows, all the yellow, orange cells here, right? Okay. Now, you always compute the sum product, so equals sum product between these. Grab the first cell and hold the shift button down and click the last one, okay? Comma, then click the first orange cell, hold your shift button down and click the last one. Okay, that will compute. Look at the way it is done. That will compute some product between what? Your cost matrix and the decision variables. So, you know, I've got two matrices now. The first one up here is for the cost. The one up here is for the cost matrix. The orange cell is the XIJs. The first matrix is your CIJ, the cost matrix. And the orange one is what? The XIJ, which you call decision variables. And do that right there. And this is going to give you 0 because as it is now, everything here is empty. And by default, Excel will fill up those spaces with value 0 for you. So if you multiply this by this, you're going to get 0 here. Now I have translated or transported or put all the network problem into Excel server. So the next thing now is to call the solver. Now, depending on the version of Excel you are using, normally you have to come right here, come to data. And if you come to data, you will, so when you click data, at the right corner side here, you will see solver. Grab the solver. See the way it is done? I grab the solver and the solver is right there. Now, my objective function is K. This green cell, you have to click it and then I'm minimizing. So select that. See that? Click your green cell and you know, in some problem, you have to maximize. But this time around, I am minimizing, okay? You will also see once you have done that, immediately below that, you will see by changing variable cells, okay? What you will do is you will click inside that cell and grab all your orange cells. So that is your decision variables. You want to maximize the distance, okay? It is your objective function, the green cell, by considering the values in the orange cells. Okay, now I have stated my objective function. I've stated the decision variables. I need to state my constraint. The first constraint I have to add is I want to make sure my decision variables here are all binary variables. So I'm going to click the first one and grab the last one, hold the shift button down and click the last one. And then I have to make sure that is what? Binary. I need more constraints. So don't say, okay, you have to keep clicking add until you are done. Okay, so add. I want to make sure what again, my out minus in column. I want to make sure from here down to here is exactly equals to from this value down to the last one. Okay, I think that is the final constraint. And then you have to say okay. Right. Then you make sure this is checked as make my variables non-negative. Okay. And you can pick your solver choice. I can pick simplex LP to solve it. Then I'll click solve. Yeah. So there's a report here that solver has found a solution. And let me say okay and see. Look at the solution right there. Okay. Now let me interpret this figure for you. So between O, see that between O and T, the shortest distance is A to B to D and to T. See that you have your 1 under A, you have 1 under B, you have 1 under C and 1 under. So you have to move from A to B to D to T to get the shortest distance of 13. And if you look at manually, if you look at the arrow from OA to B, A to B is 2, right? All right. And B to D is, no, sorry. Of course, you have to move from O to A as usual, normally. Then you move from A to B, B to D, and D to T. And if you add those numbers right there, you had this, that's 2 plus 2, 4, plus 4, 8, plus 5, 13. That is the shortest distance between O and T. I think you can use this idea also to compute critical path when you are doing project management. I hope this is very, very informative. Thank you for watching.